So this is only using transistor circuits, and today I have made a frequency bar graph. So the frequency of the input signal is shown by this 8 output LEDs. So what we will do now, we'll flash light on this LDR, and the frequency of the flashing light will be shown by this output LEDs. So we'll turn on this circuit and I will show you how this circuit works. So right now you can see 3, this is any garbage value which is getting outputted. So I will turn on this strobe application which will flash light on this LDR depending on the frequency. So we'll select strobe. So see, it's 2 Hertz. So we'll turn on 2 Hertz and it will show us 2. So I'm flashing light on this LDR which is of 2 Hertz frequency, and you can see 2 LEDs are lit on the output. Now we will drop it to 1. So you can see I will drop it to 1. .53. So now 3 LEDs are lit on the output. So we'll increase it to 6. So now 6 LEDs are on. So in this way we can see the frequency on the output. So it's 4 Hertz now and it's showing 4. I will maximum 8, and you can see 8 LEDs are on. We will drop it to 7. I think we will drop it to 6, and you can see 6 LEDs. Now we will set it to 7. So yes, what I want to say that it works, and it can only measure 8 Hertz right now because only 8 LEDs are at the output of this shift resistor. You can increase the number of LEDs by cascading shift resistors, more shift resistors. So the link is in the description. You can read how I made this circuit. The circuit diagram is also given in the blog. So the next thing what I'm going to do is, this LDR is too slow for measuring high frequency. So what we will do is, we'll change this sensor LDR with this infrared sensor. So what this infrared sensor does is, it has got one IR LED. So this is the IR LED and this is the diode. So when light falls on the white surface, it gets reflected back onto the diode and its resistance drops. So let's connect this to this board. So right now you can see that the IR light is on, and I need a white surface like a paper, or let's use this. So this is a white surface. This is a USB fan, which frequency we will be measuring. This frequency of this fan we will be measuring in a few minutes. So I'm just going to show you that how a white surface is detected. So white surface is detected, a flash goes and the output will turn on. So you can see, you will manually introduce some frequency. So you can see the frequency is 4. So for a time delay of 1 second, this much counts are passed, but this fan will rotate at a much higher speed. So all LEDs will be lit and we will not know what is the frequency of this fan. So what we will do is, we will decrease the time delay of this monostable multivibrator, and we will do that by changing this value of resistor from 82K to 10 kilo ohm. So I'll replace it to 10K. So I've replaced it to 10K. Now the time delay has been reduced. It is reduced to 111 milliseconds or 0.11 seconds. So I will show you how I calculated that in a few moments, but let us see whether this USB fan works or not. So yes, it works. So it's rotating. See, and now what we will do is, we will place this sensor right on top of this so that it detects the white surface. And what happened to it? What happened? I don't know what happened. I think there's some problem. No. So you can see the number of counts passed are 6. So you can see 6 LEDs are lit at the output. That means 6 counts are passed for a time delay of 0.11 seconds. So we can calculate the RPM of this fan, USB fan. So let's do it. Let's go on to our notebook and pen and do the calculations. So the formula for time is 1.11 RC. So time is equal to 1.11 into resistance, which is 10 kilo ohms. 10k means 10 into 10 raised to 3 into capacitor 10 microfarad, 10 into 10 raised to minus 6. So which will give us 1.11 into this 3 and minus 6, this 10 and 10 100 into 10 raised to minus 3, which is equal to 111 into 10 raised to minus 3, which is also equal to 111 milliseconds, or we can write it as 0.111 seconds. So we got the time, which is equal to 0.111 seconds. So the counts passed, as you saw, was 6. So in 0.111 seconds 6 counts were passed. So how many counts will be passed in 1 minute, which is 60 seconds? So we'll just do cross multiplication. X into 0.111 is equal to 6 into 60 will gives us 360. So X is equal to 360 divided by 0.111. So I will calculate this. So that is equal to 3243.24. So the revolutions per minute are 3243.24. So this is the RPM. So we have calculated the RPM of this USB fan. So yes, thanks for watching, and if you want to make this circuit, the link is in the description, and also don't forget to like and subscribe to my channel. So thank you.